Итак, друзья, закрывает наш сегодняшний день.
Okay, everyone. To close up our day, we will hear from a speaker who has a lot of experience both in business and in game development. His presentation is called The Horror of Mobile Graphics. Please welcome Filipp Keks. Hey, everyone. I'm a developer from Estonia. I have very varied experience in development on the server side, on the client side. And apart from development experience, I have enterprise experience, but today I will be talking about graphics. My presentation is called The Horrors of Mobile Graphics, so I will be talking about the challenges that hinder us developers from making games nicer. So let's meet. How many of you are programmers? Show of hands? Almost everyone. Okay. So which ones of you are hardcore programmers, graphics programmers? Okay, maybe this isn't exactly for you, but don't go away. Maybe you'll help me. We won't go into the hardcore graphics details, but I think that everybody will be interested. Why do I want to talk about this anyway? The thing is that over the last few years in the media, we have heard a lot about mobile phone producers saying that they are now on par with video game consoles. There's a lot of discussion about this online. People are arguing whether that's true or not, but I have yet to see a good analysis of this and have yet to see realistic conclusions. So, are they lying? Why aren't we seeing the same level of graphics on mobile devices as in video game consoles? Weird, huh? Okay, let's take a look at some numbers. When mobile device manufacturers say that they've reached console levels, they use only one parameter of the GPU. The amount of floating point operations per second that the GPU processor can perform. And here I have an overview of what we have on the market. The latest consoles, the latest generation, and the previous generation, and the latest phones. It seems like it's true. The latest phones, iPhone 10, which was released recently, and Samsung Galaxy S8, one of the coolest Androids on the markets right now, they have outdone the previous generation of consoles and are almost on par with the current generation of consoles. Actually, mobile devices are developing faster than consoles, so we may say that at some point they will outdo. So numbers indicate that they don't lie. But the question is, why do the graphics look different? So these are the pictures from the two games I just played, one from a console, one from a mobile device. And in my presentation, I will try to analyze the differences. And I will give you the answer in the end. Are they saying the truth or not? Let's start with the fact that when we're talking about GPU, when we talk about hardcore gamers who play on PCs, they think that GPUs are a huge device which has effective cooling, which is installed in the PC. But in reality, for mobile devices, the GPUs are on the same chipset as the CPU. They have united memory, and that's why it's not so simple. And we will get back to that later. Let's get started with the horrors. What is stopping us graphics developers from making games more beautiful, nicer looking, from making them as nice as the console graphics. The first one has to do with API. The problem is that the APIs that are widely used right now, OpenGL for mobile devices and DirectX for Windows Phone, they were developed in the mid-90s when GPU, the hardware, was totally different than it is now. API doesn't support multi-threading because of the global state. There is a reason for that. At that point, there was no widespread multi-core CPUs. So there was no need for multi-threading. But now this presents a significant challenge. Now CPU tasks can be sent to GPU for rendering only from one thread, unless you want to use some really complicated hacks. At the end of my presentations, I will give you a live demo. I have a small project with me here for iPhone. I have an iPhone 6s. I launched a small demo on my iPhone. It's just a small demo. GPU rendering of fractals. This is pretty complex math, but it's not about the GPU, it's about reaching 100% performance for the phone. On the phone, both the GPU and the CPU are performing at 100%. We can see that here. 30 milliseconds are needed for GPU rendering. For some reason, we have 0 here for CPU, but I will tell you about that later. CPU is performing at 40%. Oh, that's because only one core is performing. But from the profiling, we can see that only one thread is doing something. The other threads are just chilling there. So that's the problem of multi-threading. Another problem, for some reason, in the 90s, shaders, programs that are used in GPU, are shipped as a source code. It's a weird solution that was used back then, and now it's the reason for many problems on mobile devices. The amount of GPU chips on mobile devices is far larger than on consoles. There are many versions of drivers, and the tasks of compiling shaders for the tasks of the drivers, and this means that there are a lot of compilers that exist, and they have their own bugs. So coding a shader that's a bit more complicated than a basic one, which would be compiled in the same way on every single compiler, well, that's impossible. There are way too many of them. It's a big problem. Poor memory management. Back in the day, in the 90s, API developers believed that GPU and CPU memory will always be separate. Just because for rendering GPU, there's a need for faster memory, and that is why they were separate. And here on this picture, the GPU and CPU are in the same place, and they use the same memory. But despite that, API forces to copy the GPU data from one part of the memory to another part. And there's really no need for that to be done. It's outdated. So the API, the old API also has no programmable blending. In the past, blending was executed in the hardware. So there was a limited amount of functions to blend together the pixels. But now, I don't know if all chipsets have this, but there is program blending for mobile devices. There's no access, though, to this programmable blending because of API. It's possible to use extensions for that, but this is difficult to use. It's not standardized. You shouldn't count on it if you are doing a multi-platform, if you're working on a multi-platform application. And the last thing is that there's no performance guarantees. So the GPU driver can start compiling a shader in the middle of rendering. So a new texture format was uploaded to the memory, and suddenly the compiler, the driver decides that I need new shader, and the application freezes. This is impossible to control. So using the old API, I can't say that all of a type of operations should be performed now. It will do them whenever it wants. So what can we do about this? Probably everybody heard that last year a new generation of APIs was announced. I was talking about old problems. The community has been talking about them for a decade. And the key features that appeared in the new API have to do with the global states. So now many threads can be used. There is memory management. So using Vulkan API, for example, you can ask whether the GPU and CPU memories are separate or if it's the same memory. Theoretically, there's no need to copy data for rendering from the different memories because it's the same. So back in the day, OpenGL was separate for desktop devices, for consoles. And now all the APIs are the same for mobile devices, for consoles. But there's a downside. There were two standards, OpenGL and DirectX. Now there are three. The war of standards has gotten even worse. Now we have DirectX 12, Metal. They're very similar, the three of them, but a bit different. For graphics programmers, life has gotten a little bit worse. Some people say that the new API generation is too complicated for programming. Probably that's true. But actually, those guys who are working directly with API graphics, there's not that many of them. Maybe your company develops their own in-house engine, so they have a group of people who work with API, but the rest of them are working with the rendering based on that. So this complication doesn't make game production more expensive, and indie companies usually use game engines that are already existing, Unity, for example. So does anybody program browser games on WebGL? Okay, so you probably know that WebGL said right away that they will not use Vulkan APIs because it is too complicated, according to them. Performance, they say, is not so important for graphics, at least for now. That's what they think. This means that web games will not enjoy the same quality of graphics as mobile and console games. So, when will we see this bright future? Let's take Apple. They're pushing their metal pretty aggressively. A lot of programmers are forgetting OpenGL and using Metal. I think there are a few guys at this conference who will talk about this in detail. But if you're creating a multi-platform game for Android and other platforms, then most likely you will be relying on the new API for the next 10 years. You will have to use OpenGL, WebGL X, unfortunately. The most horrific horror there is for graphic developers is heating, temperature. Like I said, when I was commenting this side, the device on the left has efficient cooling. The small one, the small chip on the right, that's, by the way, iPhone A9. The small chip on the right can't have cooling like that. Just imagine your phone has this huge cooling device. Nobody would buy that. So chips are getting even smaller, phones are becoming thinner, and the cooling that's exists there is not enough. And phones are starting to overheat. Every phone has a special mechanism which protects it from burning. Without it, the phone could just burst into flame. The mechanism is called throttling, which limits the frequency of the CPU in order to cool down the telephone. This works great for the device. It won't burn down, but it's terrible news for user experience. The application starts to freeze and the user doesn't even understand why this happens. The worst comes when you are trying to create a VR mobile app, then, you know, the player will just get nauseous. It's terrible. Because of this problem, we, graphic programmers, cannot use 100% of the phone's resources. We know that if we use them to 100%, it will overheat and the player will not be able to use this game. So developers who are working with consoles, they can use 100% of the resources and not worry about any problems. So why does this happen? Don't mobile phone manufacturers know about this? Of course they do. By the way, this is a pretty recent problem. I will talk about this on the next slide. And phone manufacturers do know that customers look at specifications when buying. And the speed of overheating is not part of specifications, but performance, yes, that is the part of the spec. So when the customer looks at the specification, it will choose the device with the highest performance at the same price. And the customers don't know that he will never be able to use these capabilities on the phone. So it's a small lie, it's marketing. Marketing is guilty. I have nothing against marketing, but it does lead to some problems once in a while. So I did a little benchmark analysis of Galaxy S phones from 4 to 7. I wrote a test shader which loads up the GPU resources to 100%. And I saw how much it can render into 20 milliseconds, vertices and pixels, and I got these statistics. I took measurements after 10 minutes after the device has been working like that, and that's what I got. Galaxy S4 and S5, just like I expected, rendered pretty well. 500,000 vertices, almost 1,000,000 vertices, just as expected. Their processor is more powerful, and these two devices did not overheat at room temperature. What about Galaxy S6 and 7? Overheating throttling, and as you can see, the performance is much worse than for the previous devices. So the latest phone which was balanced is actually Galaxy S5. This means that you can create a game for Galaxy S5 which will load the resources to 100% and the phone will not overheat. Unfortunately, this is not true for S6 and S7. If I'm not mistaken, both of those were released last year. So basically, this problem stems from 2016. It's pretty new, and unfortunately, nobody is speaking about this problem. You won't find a lot about this. Phone manufacturers are trying to keep it quiet. Reporters, the media, they're keeping quiet as well. Maybe in due time, they will bring it up. I don't know. So how can we fix this? How can we fix overheating? Of course, the solution has to come from the vendors. They should admit that spec wars will lead to no good. Marketing has to patch things up with the technical production side of the hardware. And they have to integrate the chipsets in their devices, which will be balanced to provide for natural cooling. And by the way, little by little, this is happening in Apple. For some reason, they're not public about this, but you can see this in their specs. Few people know that the iPhone, starting iPhone 7, 8, and 10, have the same GPU performance of about 350 gigaflops. They didn't increase the performance in the later models. The reason of that, I think, is that they don't want the devices to overheat too much. Although when they release a new phone, they say that we just released the fastest telephone ever. The speed is the same, they're lying. There is a little bit truth to their word, thanks to Metal API. Thanks to Metal API, using the same mathematical computation speed, you can create higher quality graphics because you can use programming, blending. The hardware performance does not increase. Probably you have heard that Apple, all of the Apple mobile phone devices used Power GPU. And Apple 10 is the first to use a custom GPU created for Apple. It has the same performance as Power Ver. The difference is that it uses a bit less energy. As far as I was able to see in the brochures and the blogs, this was done to save battery life. But I think they did it to fix overheating, to limit overheating. What will we see in the future? Perhaps we will see a new technology for more efficient natural cooling without making phones larger, without a special cooling device. Maybe a new material will be invented for the telephone case, or maybe there will be a new technology which allows to increase performance without using more energy. Or maybe they reached the ceiling of performance, and in the nearest 10 years it will not be any higher. Singularity? I don't know. Okay, so now I will show you that demo that I mentioned. So I launched the demo 10 minutes ago, and it's still working at 30 frames per second. You know, I expected that throttling would start. It's a demo effect, I guess. Let's take a look at it at the end of my presentation. Maybe that's what will happen. Maybe it's cool here, so that's why it's happening like that. So what can we as graphics programmers can do about this? The latest phones released last year and this year have the same problem. They overheat at room temperature. What did we do at the project where I worked last? We measured play session length. It was about 15 minutes. And we thought that if for 15 minutes we can maintain a stable FPS without throttling, then this would make enough people happy. Enough people happy with us. So just by trying many things, we can now utilize about 60% of CPU and GPU resources on the market-leading devices. That's not... I think we can do... It would be nicer if we could do better. If the play session length is longer than 15 minutes, then you have no choice than to lower this limit to 50%, 40%, depending on how long the play sessions are. The next horror: tools. Unfortunately, hardware manufacturers are usually bad software manufacturers. So all tools released by hardware manufacturers are of a very poor quality. Mobile phone manufacturers are present on the market and they have their own chips, several versions of these chips. And this means that there are more profilers and tools for analyzing GPU performance. There's a lot of them, and they're not very effective. They don't show the right information, they are difficult to install. So, for example, the tools produced by Apple are one of the best ones, but even this tool that I just showed you, the primitive profiler, just the simplest one, it is telling us that the CPU is not working. But if I look at another tab, I see that CPU is loaded at 15%. Why is this happening? Because of the profiler. Nobody knows how to work with these profilers. What's worse is that many mobile phone manufacturers are closing channels which can be used for connecting to the chip. Apple used power technology chipsets, but there are no tools of Apple VR which can connect to the iPhone. They blocked it. They want developers to use their tools, the tools created by Apple only. And they're not the only ones to do that. Some phones can't connect to any tools. And even the mobile phone manufacturers don't have their own tools, so they're impossible to profile. How can we fight this? Will there be better tools in the future? Probably not. There are a lot of GPU manufacturers, and it's not likely to decline. Mobile phone manufacturers don't like to invest a lot in software. So you can, for example, make your own tools. For example, if you work in a large company that has the resources to do this, to create your own analytical tools, but if you're a small indie studio, then you do not have this opportunity. What do you do in this case? You can use a few tricks. Few people know that Chrome has its own GPU profiler. I can show you. Just go to Chrome tracing. What's good about this profiler? It can save and load the data in JSON format. And this format is described in the Chrome documents. So all you need to do is just export the data in the correct format and use Chrome as a visualization tool. I think Unity can do the same thing, but I never tried it. Anyway, there are ways to make life easier. Horror number 4, diversity. This has less to do with iPhones, more with Androids. There are a ton of different chips, tons of different combinations of GPUs, CPUs, and what's more is that a lot of mobile phone manufacturers use really odd combinations of chips. So they use a really high performance CPU and a low performance GPU. And they can't work together efficiently. These capabilities cannot be used efficiently. And to address all of this, PC game manufacturers allow the player to choose the graphics configurations. You just go to graphics settings and you can choose from a plethora of advanced settings. You can substitute different algorithms, but you cannot do this for mobile phone devices. These players are not hardcore enough to understand what it all means, what all of these screen space shadows and so on mean. For mobile phone players, you need automatic graphics configurations. So what can we do? For example, on our project, we chose a model of the iPhone, and for every model of the iPhone, we hard-coded the settings that work there and tested them in advance. For Android, there are too many models using Android, so we took the models of the GPU, CPU chipsets. Sometimes it works, sometimes it doesn't. Like I said, some configurations are just not efficient. But we can't make everybody happy, we just need to make most happy. So in conclusion, what can I say? No. Mobile graphics did not reach the console levels. Will they reach it in the future? I doubt it. Maybe right now we reached a plateau of graphic performance on mobile devices, and nobody knows how to overcome this plateau. There are no solutions. We need a new technology. So maybe it will stay like that for the next 10 years, or maybe we will see something new next year. And the biggest problem is the business side of things. Capitalism. Mobile devices that you all have right here with you are not made for graphics. They are made for reading emails, for Facebook. Games will always be a bonus feature for your regular mobile phone. And no matter how much marketing specialists try to show us how these phones can render, this is just advertisement. They're just trying to figure out how to advertise the user who just needs to read his email. What does this mean for mobile phone graphics developers? I think they can have a lot of fun for the next few years. You are guaranteed not to get bored. And if you play games who like detailed, beautifully rendered pictures, use consoles. Don't play games on mobile phones. That's basically it. But I can show you my blog, philippkeks.com, I have a blog post on the same topic. It's a bit more detailed. So that's about it. Are there any questions? Probably graphic programmers, right? Have some questions for me? You got it. I have a detailed graphics question. You talked about programmable blending as a really hardcore feature. And I was just curious, can you name any examples where this feature is of help? Sure, I can. Programmable blending can be used for color correction. You just need one pass to do this. Right now, without programmable blending, you need two passes for color correction. Frame buffer, and then you need a pixel shader after that. You can just use blending to do this. Some Finnish guys at this conference were talking about this, or are talking about this, maybe tomorrow. I don't remember when. So this programmable blending, it just gives the capabilities to read the pixel values. I'm not sure I understand the question. That's fine. I understand. Okay, that's the most important thing. Any more questions? Hi, thanks for the presentation. I have a question about device testing. You said that you have all iOS devices tested, and for Androids, only for the chipsets. Did you ever want to test it for flagship devices? So testing not just the chipsets, but something else. I'm talking about the flagship devices, the most popular ones. We haven't tried it yet, but probably it's possible you can choose the most popular devices, but it's a possible approach. And the least popular devices, we can just say that they have a generic graphics level. But we just decided to test the chipsets. I'd like to add to the previous question. Samsung S7 has over 10 different chipsets which are used in different markets. So this means that if we test a specific flagship device, could this lead to a problem? What do you think? Yes, you're right. The same phone model has different chipsets oftentimes, but they are comparable. Manufacturers try to use this chipsets of the same performance. So if we focus on chipset model, then they will provide for the same level if everything is configured correctly. Did I answer your question? Hi, thanks for the lecture. I have a small question. You were talking about the latest iPhone versions, 8, 9, 10, that the GPU performance is the same. Where is this information from? Different media sources, blogs, Wikipedia. It's just that when you were talking about this, I Googled this, and in Wikipedia, of course, it's not super reliable, but according to this source, performance is growing. And how much does it say? 100 gigaflops for 8, and for iPhone 9, it has 200. So starting A10, they haven't increased, but for A8 and 9, they did grow. iPhone 7 had A10, and the other versions have A11, but the performance is the same. Hello, thank you for the presentation. I'm not a programmer, I'm more of an artist. Oftentimes, the graphics quality doesn't only depend on GPU, but on the features that
Актуально для ГПУ, для мобильных телефонов?
Это очень актуально, но на мобильных телефонах большая проблема, что слишком большое разнообразие разных версий. Поэтому хочется все-таки, чтобы она работала везде. И чаще всего используются только те API, только та функциональность, которая есть везде. И только для топовых девайсов делается отдельно. Допустим, мы в нашей игре, последней, где я работал, мы делали 3 уровня графики, и третий, последний был именно, использовал фичи только топовых аппаратов, и мы не использовали фичи, которые есть, допустим, в айфоне, но нету в андроиде, что мы ориентировались все-таки на кроссплатформенную. То есть, да, есть такая проблема, она еще хуже, чем для PC.
it's not just a software problem. Some hardware supports certain features, and others don't. We use only those extensions which are standardized across different platforms. If some extension exists only on one platform, we don't use it.
So we keep catching our speakers in the hallway and putting cameras in front of them. Hi, please introduce yourself.
My name is Samuel Ranteskla. I work for Microsoft as a principal program manager out of Sweden.
Okay, Samuel, so let's talk about games. What's your favorite game?
Well, I wish I played a lot more games than I actually do. So I have to go back into the past. Like one of my really favorite games is Jag the Lions 2 from like 92, 93. I think it was made here in Russia, if I'm not mistaken. Civilization, always been a big fan of that. And then the Enemy Unknown UFO trilogy from the 90s. There's so many games, I mean, it's like impossible to select one. But they're all strategic games, the ones that are my favorite.
Yeah, you're obviously a tactician. That's commendable. But do you remember the very first game you've ever played?
Decathlon, probably on the x86, somewhere around 84.
Wow, that's... I don't even remember that one.
It's like you basically play Decathlon and you just hammer at the keyboard to go faster, like 10 different sports events. Played it like crazy. I was 8 years old then.
Wow. How did you get into the gaming industry?
It was by chance, actually. So I was studying at Uppsala University, doing computer science, and they had this fair where companies were meeting the students. And there was these two guys that they've started a game company in the basement, and they wanted somebody to write a BSP tree, binary space partitioning tree. And I was looking for my thesis, so I figured let's combine those. So I joined them, I wrote my thesis in the games industry, and then from there on kind of like just went on. So this was 2000.
But now in 2017, what's your favorite and least favorite thing about game dev?
I mean, I think the games industry is awesome. Great place to work. There's so much passion. There's skilled, very intelligent people. I think that's my favorite thing. The least favorite thing is that, which I covered in my speech a little bit, I think that we're looking a little bit too much at how do we turn time into money, rather than seeing like how do we educate our kids. I really want to, that's my passion myself, is like take this experience, make our kids better tomorrow than they are today. I'm a parent as well, so that's coming from that.
Well, that's a very noble thing to do.
I don't know if noble, just I think it would be a good thing for us.
Definitely is. About your speech, did you have any interesting questions that maybe stood out?
Yeah, there was some interesting questions, like if we look at mixed reality, what's going to happen with that? What's the dangers with that? I couldn't really answer them because let's see what happens.
But if you were a part of your own audience, what question would you like to ask yourself?
That was a tricky one. Are you sure that you're right?
Are you?
No.
Well, we can be sure 100%, but still, we're trying to foresee the future here. How do you like the conference?
Love it. St. Petersburg, great place. Wargaming, excellent hosts. It's a great place to be. You should come to the next one.
Definitely do. Say, if you had the chance to go back in time to when you just started working in the industry and give yourself one advice, what would it be?
Try one of your ideas out.
That's very good. Thank you very much, Samuel. I hope you like the conference. Thank you. We got another one of our speakers here at 4C and would like to ask him some questions. Hi, please introduce yourself.
Hey, my name is Eric and I'm the CEO of the Do Dreams game studio based in Helsinki, Finland.
Very nice to meet you, Eric. Tell me, what's the very first video game you've ever played?
I guess when I was a little kid, my dad was in banking and he had a lot of business trips and he went to Japan. And he brought me one of these Nintendo handheld, like small games. It probably was Donkey Kong. So that's my first memories with gaming. And then I played a lot of Oil Panic with the Disney characters, so fond memories with those. Favorite gaming memories? Well, I like games that I can play with my friends. I remember when I was in high school, we'd go visit my friend's house and we played a lot of these like sports games together, like NHL 95 and some F1 racing games. So I would say that maybe NHL 95 is the game that I have played most with my friends, and I have fond memories of starting after school and then realizing this like 2 a.m. and knowing that my mother will be very angry when I come home late.
That happened to all of us, I think. How did you start in the video game industry? What led you here?
I was earlier a marketing lecturer at this business school in Helsinki, and then at some point I realized that instead of talking about business, that I'd like to do business myself. I had my own startup for 3 years, did different kinds of entertainment apps. I was interested in storytelling in apps and online and social media. After that, I did that for 3 years, failed miserably. But I guess the one thing I learned was how to test concepts early with real customer data, because when you have little money, you need to be sure that you're spending it wisely. And I had the opportunity to join an existing team, so I joined Do Dreams as a CEO, and together with the wonderful team I have there, we started with these mini games. Eventually came up with Drive Ahead, which is our current franchise that we're developing.
Sounds great. Tell me what.
Okay. Yeah.
Just a bit in the camera.
Yes. Yeah. Okay. Yeah.
So what's your favorite thing about the video gaming industry, or maybe just something you strongly like about it?
I think my favorite thing about the gaming industry is the community of developers. So traveling around the world, meeting wonderful people who make games, and talking to people and learning from them. I think it's really cool how in gaming people are very open to share their experiences about the business aspect of running a game studio, management stuff, tips and advice on scaling and growing a company. It has been very useful for me, and hopefully by giving talks at events like this, maybe I can give something back to the community.
Oh, you definitely are. Anything that maybe irritates you, or something you don't like about the industry, strongly dislike?
Well, I think in recent years, games are developed with data and analytics, and that's of course very important. And I think all the creative decisions should be based on data. But what I've noticed is that studios maybe give up quite easily on games and their communities. So we have found that if we really invest in the community and take care of the players by making regular updates to the game, thinking of the game not as a product but as a service, then the community will support you through difficult times.
What trends do you think are going to persist or maybe appear anew in like a 10 years time? Let's make a prediction.
Oh, that's a very tricky question. So with everything developing so fast, I guess it's really difficult to say. I'm very excited about AR. So our studio, we launched our first augmented reality game, Drive Ahead Mini Golf, just yesterday. So I'm very interested in seeing how this market will develop in the next year or two. If you look at 10-year perspective, then maybe games will be everywhere. Maybe like your glasses could be a platform for playing games.
I'd love that.
Yeah. So maybe it will be very interesting to see what kind of sessioning games will have when people could basically be playing all the time.
What do you think is more important in a game, like one of its aspects, the ever discussed questions, the graphics, the gameplay, the game design, the storytelling maybe?
We usually start with a fun core gameplay. So of course we want to make fun, cool games, but we found that that's not enough. So you need to make sure that your players have a reason to return to the game often, and they want to return with their friends. So I think planning this progression and making sure that there are some kind of events like live operations, I think that's very important. And though everybody knows monetization is important, like just thinking of the the path the player takes in the game, and when are they presented with opportunities to spend money or watch videos or do something like that, like connecting the revenue model with making the game experience better. I think that's very crucial.
Do you have a vision of a video game you'd like to create if you weren't restricted in absolutely no way, like financially, creatively?
There's only one right answer to this, and that is that if we would have no financial restrictions, we would be doing the exact same thing that we're doing now. So I believe that the format that we have, developing games with minimum risk and investment, testing concepts early with players, and launching games thanks to this wonderful, large and active community that we have with Drive Ahead, is the way that we would want to do it, regardless of what kind of budget we have.
Sounds fair. Let's come back to the real world for a moment. What do you think about St. Petersburg?
St. Petersburg is a wonderful place. We've been blessed by wonderful weather this time. I heard from the locals that we're very lucky to enjoy this nice weather. I've had the opportunity to visit St. Petersburg 3 times during the last year for a couple of events, and I'm always excited to meet the local developers. Our Drive Ahead game on Android, Russia is the largest market for us, and this is something that we want to understand better, like why people like the game here, and see how we as a studio could be more present in Russia and be closer to our fans, the players, on Russian social media. So that's why I'm always interested to visit Russia and meet people if I have the chance.
Well, now you have the chance, another one, at this event 4C, and what do you think about it?
I've had a chance to talk at many international events in China and the US, GDC, and places in Europe. I think 4C is the best organized event I've ever been to. You guys are taking really good care of the guests, and the lineup is awesome. So I'm giving a talk myself, but the rest of the time I have a full schedule of listening to presentations. So usually when I go to these international conferences, I'm quite tied up with meeting partners, but here I'm really going to enjoy going to the talks myself and hearing what the experiences people share.
And if you were interviewing yourself right now, what question would you like to ask yourself?
What question would I like to ask myself? I'd probably ask that, why do I have this wonderful beard?
Why do you?
Well, I'll tell you guys a secret. So I'm actually the great-grandson of Santa Claus. And that's why I have this beard, and Santa Claus said to me that you have to learn how to bring people of the world joy. So that's why for the next about 200 years I'm going to be the CEO of the Do Dreams game studio. And one day, in about 200 years, when my beard is all white, then I will become the next Santa Claus.
Really looking forward to it, and from the presents from you. What are you looking forward to? What's maybe the speech that you'd like to hear most? Anything specific?
I love all these demos and case studies that people do. I really like the talks where people go through some project and go through their experiences. So I have several of those in my schedule.
Great, sounds exciting. And now children all over the world are excited for a new Santa. And I hope you have a good time here. Thank you.
Thank you.